quick. Think of a joke with boxes.
The rules of boxing.
I don't know if
Voxel.
he's dead or alive until I watch inside the box.
What's in the fucking box?
Let's think inside Schrodinger's, Wait, what? My new bestie just dropped a bomb on me when he shared his post on Reddit alongside me. Woohoo! The key idea I stole from this post was the concept of low-resolution occupied boxes. Here's the promise of storing more or less the same information than with occupied bits on less than half of the size of them. Promising, right? But wait, what was this occupied bits thing though? You may already know that I work with directed acyclic tree graphs to store voxel data in my open source voxel raytracing engine. Occupied bits refer to binary data stored within each node, describing each of its children's occupancy. It's an acceleration structure aiming to support rendering efficiency by helping the ray skip large empty areas during ray iteration. Occupied boxes are basically a challenger to occupied bits. For a measly 30 bits, you can store 6 coordinates, each having 5 bits, which results in each point rocking a value between 0 and 31. Combining this with the actual boundaries of the node, you can get a structure which stores the information about the node's content on a resolution which points beyond it. Meaning, this resolution can suggest data about the node's children even before they are loaded into memory. Peeking ahead like this, it is possible to avoid loading parts of the data not relevant to the current rate, so it saves time essentially and cache space. So if occupied boxes could be used in place of occupied bits, then the amount of data stored for a node can basically be halved. Neat. Programming montage time! After actually implementing this, I've got the following results. It's not the best data, I know, let me, As you can hopefully see, this concept didn't really live up to my expectations. The reduced data size actually comes with reduced information. This is the best representation of the kind of data that challenges this stack. A diagonal line has a large bounding box, but there's barely any data in there, so an occupied box around this line contains a relatively large amount of false positives, as opposed to occupied bits, which does pretty much right in this case as well. When we instead look at square-shaped data, the two concepts perform pretty much the same. Picking up less space is not really a good selling point when occupied boxes just can't replace occupied bits. So, in the end, this is not something I will be including in my library. Unless you know something I don't. Check out the implementation. You can do that as the stuff's open source. And since I already mentioned occupied bits, these investigations just reaffirmed the importance of it inside the library. Essentially because the real-time streaming logic, we may have incomplete information within the GPU while iterating the array. It requires redundant information to be stored about the nodes within the tree. The structure relies on children pointers to advance to its next node, but if a child pointer is not uploaded yet, simplified representation is displayed instead of it. To detect when the simplified representation needs to be displayed, the child pointer needs to point to empty, and the occupied bit needs to suggest that there should be something there. This is in a sense redundant information, but the occupied bit can still be used as an acceleration structure, so it's all good, right? Well, yeah, that's true, but since I've decided to allocate another few nights getting to the bottom of this, instead of shadows or lights, I've had the chance to check the actual results with the lookup tables I've implemented earlier as an acceleration method, courtesy of Douglas.
The idea behind bit masking is that when a ray travels through a 4-cubed brick like this, it's only going to ever visit a subset of the voxels inside. For example, this ray is moving up and to the left, so we know that it will only ever hit voxels that are up and to the left. This is the core of the bit masking optimizations that I added to my engine.
So I look at the results and they were not convincing. Maybe because of the structure this library is specifically working with, because it uses bricks and the actual tree structure is very shallow. This might explain why none of the methods seem to spare any noticeable runtime, which is sad. One nail on the coffin of Occupied bits is that it needs a 64 kilobyte lookup table to help accelerate rendering. It may occupy cache, leading to slowdowns in some cards and in some cases, which is not ideal, but in isolation this is not, let's say it's not a big deal. But here's where I want to draw a line. So for now, I axed the lookup table implementation as well. Now, Occupied bits are only stored for one essential function it provides, which is storing redundant data for reference during voxel streaming. Do you think I made the right choice though? I've benchmarked the difference on multiple cards, scenes, shares. I went quite far to make a justified decision, and I'm really hoping that going this deep and obsessing this much on performance will pay out in the long run. So, tell me, what do you think? I'd love to hear from you, and thank you if you're still here. I am deeply honored by your attention. Honestly, I was always hoping to build up some professional connectivity through these videos, and here I am, working together with some of the most professional and energetic and smart people. Well, I rarely have the opportunity to. So I don't really want to let this go. But okay, until next time, goodbye.